Find the points on the graph of y equals to x cubed minus 3x squared minus 9x plus 16 where the graph has a horizontal tangent line. Now, when you hear the word tangent line, you should immediately think about the derivative because the derivative gives you the slope of the tangent line. But what is the slope here? Well, it says horizontal tangent line, and horizontal lines have slope equal to 0. So that means we're looking for points where the derivative, if I call this as f of x, then the derivative has to equal to 0. That's what we need to solve. So let's try that. We have y prime, we're trying to differentiate x cubed minus 3x squared minus 9x plus 16. These can be differentiated using the power rule. 3 comes down, you subtract 1 off of 3, so it's 3x squared. 2 comes down, so it's 6x. And x prime is just 1, so it's 9. And then 16 is a constant, so it's 0. And we're looking to find out when 3x squared minus 6x minus 9 is equal to 0. Now this is a quadratic equation, so that means at least we can use the quadratic formula to solve this if we can't find out how to factor. That would be very unfortunate because quadratic formula is ugly. But here we see that everything is divisible by 3, so why not divide by 3 and see if we can get something simpler? We have x squared minus 2x minus 3 equal to 0. And wait a minute, I think I know what this is, because if you multiply 1 times negative 3, you get negative 3. 1 plus negative 3 is negative 2. So I find that there are two numbers whose sum is negative 2, whose product is negative 3, which in fact, it's negative 3 times positive 1. Oh, that's nice, because then I know that x equals to 3 and x equals to negative 1 are the two solutions. Okay, so these are the points where points on the graph where the graph will have a horizontal tangent line, but it's actually not the point, it's just the x-coordinate, right? And it's asking for the points. Now sometimes your question will just ask for the x-coordinates. Find the x-coordinates of the points on the graph of and so on and so on. In that case, you stop here. It's a very simple question. This is still simple, but if you're being asked for the points, you still have to figure out the y-coordinate. So you have to figure out y-coordinate for each case. So when x is 3, you have y equals to 3 cubed minus 3 times 3 squared minus 9 times 3 plus 16. 27, that's also 27, so these two cancel. It's minus 27 plus 16, which is what? 27 minus 16 is 11, and it's a minus 11. And this means that the point 3 comma negative 11 is a point on the graph that has a horizontal tangent line. Okay, and then if you have x equals to negative 1, then y would be negative 1 cubed, which is negative 1, minus 3 times negative 1 squared, which is minus 3, minus 9 times negative 1, plus 16. Let's see, that's negative 1 minus 3 plus 9 plus 16, and that's going to be 21. So we have this point negative 1 comma 21. So that's the answer. But let me try to explain to you by graph what this means. So the answer is you have 3 comma negative 11 and negative 1 comma 21. Now the graph of cubic functions, especially when this is positive, we know that the end behavior is like this and this, right? It goes to negative infinity going left, positive infinity going right. And if it's a cubic function, it will have at most 2 turning points. And we know that we have 2 turning points because it's actually these turning points where you have a horizontal tangent line, right? So what's cool about this question is we actually figured out the exact coordinates of the turning points. So let me explain what I mean. So let's say 1, 2, and 3. Here's 3. And let's just call this as let's call this as something like negative 11, and we'll call this as positive 21, and this is negative 1. Okay. And if you want to draw the graph, well, it has to pass through negative 1 comma 21, right? This point here, and 3 comma negative 11 has to pass through here. I also know that the y-intercept is 16 because if you plug in 0, it's 16, right? So it's going to pass through this 16 here. And the graph, because these are the two turning points, you're going to get something like this. Okay. So what an achievement. We actually not only were able to figure out which point in this graph will have a horizontal tangent line, but we also figured out the generic shape of it to a high accuracy. And this is something that we're going to revisit later on in the name of this curve sketching.